Problem set number 3, question number 2. This one we didn't have to do anything to the data set. I by default throw on some filter buttons, but I don't think we even had to use that. What we did need to do was make at least one, and in my case, bunches of pivot tables to summarize the data for us. Part A asked us for the ice patch size that was most likely to have an artifact in it. Well, here we just make a pivot table that has the ice patch size and the sum of artifacts. So the sum part is important. Remember, a pivot table, if you're dealing with numbers, will offer you the option of doing either a sum or a count. So perhaps confusingly, count is the number of rows where a certain thing would happen. So a count for large would say, well, how many rows had large in there? And it would ignore that there were 13 artifacts in this particular large one. We want the sum of artifacts. It is important that there were 13 artifacts in this particular row. So always keep in mind when dealing with pivot tables and Excel, the difference between counts and sums. So here we have, again, our ice patch size and the sum of artifacts. And the pivot table will just do these numbers for us. We see, well, the medium ice patch size had the most number of artifacts, so it has also the highest probability. I didn't ask you to calculate what that was. It would be 83 divided by 145, but just by virtue of having the largest sum, it will also have the highest probability. That's part A. The next ones are doing pretty much the exact same thing. We ask a pivot table to take the elevation categories and the sum of the artifacts in the elevation categories, and we pick out the category that has the largest sum. And for us, that is the 1900 to 2100 elevation. That's part B. Part C asks you to make a larger pivot table that has the ice patch size and the elevations. Ultimately, we're still looking in our table and finding which particular combination has the largest sum, the largest number of artifacts in it. And so that is the medium category at the 19 to 2100 elevation. This last one, or I guess it's not the last one, but the next one asks us for the probability, or not a probability, for which ice patch size given that we are restricted to the 1500 to the 1699 elevation. So here our pivot table is very short. We can actually look at it from here. We are restricted to this 1500 to 1699 category. So of the ice patch sizes in this column, the medium by far has more artifacts. It in fact has 94% of the artifacts in it. So if we are restricted to this column, we want to look in a medium-sized ice patch, highest probability. The last question, perhaps a little vague, maybe too vague, my apologies if so. The table above, or the calculation we just did, makes it look like if we went out into the hills tomorrow to some mountain that was between 1500 and 1699, and we found a medium-sized ice patch, that we would have a 94% chance of finding an artifact. So the question was attempting to make you look at that number and think, well, is it reasonable that if we just chose a random mountain at a 1600 meter elevation with a medium ice patch, that we're almost guaranteed to find an artifact? And the answer is no. At least it's most likely no, because our data set, and this calculation has a hidden assumption in it, that the probability here assumes that, or it's based on there being an artifact in a medium-sized ice patch between 1500 and 1699. The chances of there actually being an artifact is most likely much smaller than that. So we can't find anything that's not there. And our calculations here in the data are all for artifacts that or ice patches and elevations where artifacts were found. There's no data on ice patches and elevations where artifacts were not found. And so that underlying assumption that an artifact is actually in the location we're searching would drop this probability from 94% to something much smaller and presumably more reasonable. Again, the point of this question wasn't really a math one, but to get you thinking a little bit more on the assumptions that underlie the the data that you're looking at. Do things make sense? Does it make sense to have a 94% probability of finding something?